Thanks for having me, everybody. And I hope I can give you guys an interesting, quick introduction to the work that we're doing at Mass Timber Technologies and trying to drive engineered timber into the construction environment by all means necessary, or as best we can, at least. So just a quick introduction for myself. I'm Marcus van der Hoven, co-founder and managing director of Mass Timber Technologies. We're a mass timber prefabrication business based in Germiston, where we really focus on the technical development side of projects from residential all the way through to large and commercial developments. And then, obviously fabricating, doing the lamination, machining, packaging, and all of that, getting material to site for construction. So in a nutshell, that's more or less what MTT does, but we'll dive into all the nuances in this chat. So just to kind of contextualize a couple of the reasons in terms of why we're doing it, and I won't go on too long about this. I'm sure everybody in the room is quite aware of the impact that our profession has on the broader environment. So understanding that over the next few years, Africa is kind of pointed to be one of the highest development rate sort of contexts in the world. We seriously have to think about what we're doing in terms of finding alternative solutions to our very CO2 heavy industries like cement and steel, which I'm sure as engineers you guys really love to work with. They're absolutely fantastic materials, but we're certainly paying a lot for it in the environment. And there are better alternatives out there to work in a hybrid fashion. Another thing in terms of just, and this speaks not only to engineered timber, but also kind of the technology that we're starting to adopt, considering what we're putting out into the environment as carbon emissions compared to our performance financially as a country. We can see that our processes certainly aren't really efficient. So by leveraging a lot of the elements that we're talking about today, we hope to see a slightly bigger change in terms of how we're participating in a cleaner built environment, and also something that's just going to be more sustainable for us to tackle these large problems with. So typically right now, we're really focused on breaking things out of the ground, throwing them into a furnace and turning them into materials that we build with. Whereas at MTT, we're trying to look slightly towards a slightly more renewable system, leveraging these things called trees that grow prolifically in our country and all over Africa, in a way where we can start finding a way to create structures that are a little bit more serious than a windy house or a fence like we're used to building with timber typically. Once we start considering the impact of this, understanding that 1 cubic meter of timber can sequester up to a ton of CO2, we start understanding that the opportunity here really favors this material to work. And this goes into a lot of different themes. Ultimately, we're watching developers and institutions that are funding developers and their projects becoming more stringent around how they're dealing with their embodied carbon and what their solutions are towards building this massive fabric without putting so much stress on the environment. And all of these parameters like EDGE certification, your green building certificates, etc., all of these certificates are requiring a slightly higher bar every year, making it more and more difficult for developers to really wrap their heads around a solution. We've got big declarations coming out, and a lot of these things we also kind of have to take with a pinch of salt. There's a lot of consultants out there saying this is the future, this is how we're going to do it. We signed that document, but there's no real reason for it. But this is starting to become a bigger conversation, and the more of these sort of declarations coming out, and hitting the tables of developers and portfolio managers, we really have to start understanding what we can do to have a solution out there as building professionals in general. And as you've seen, and I'm sure a lot of you guys have probably noticed on your LinkedIn feeds and what you're reading in the sort of engineering news nowadays, is that there's a big drive to move from this mineral-based construction material system that we're used to into something that's slightly more circular and feeds into a bio-based renewable system. And this is a trend that we would like to ride the wave of and innovate inside of. And it's really critical that we get the engineers, the architects, the quantity surveyors especially, all talking the same language when we start transitioning into a new building environment. So MTT, we've been around for about 3 years. It has been a very interesting and tough 3 years building the system. We managed to raise a number of different investment rounds, and we are now at least in a slightly more comfortable position when it comes to developing into something that can produce some serious volume into the environment, and kind of meet the pace and the demand that we're starting to see for this material come forward. So we have about 3,000 square meters under roof, planning to extend that a little bit now with some additions to our structure. And we really focus on being able to actually participate, much like you would imagine a large steel fabricator would inside of the built environment. We're trying to sort of model that scale, and try and find a way to access more areas in the market as possible. So the first sort of technical introduction point, we'll basically just run through kind of what the materials are, what we're making, and how we see these things come into place. And then we can kind of dive into some slightly more detailed nuances around detailing and drawing with or designing with this material. So I'm sure a lot of you have seen these sort of wonderful images of these clean timber structures. And this is ultimately the direction that we're trying to move in. We're replacing about 70 or 80% of the built fabric of a structure, of a built structure, with timber in various forms. MTT, we really focus on producing 2 products as our sort of initial entry into the market, and using those 2 products to kind of address as many different building conditions or requirements as possible. So cross-laminated timber, that's the one that's slightly more slightly newer into this environment. I think we're one of 2 producers in the country that make it, and it is basically the same concept as your laminated timber beams that you're used to, your GLT, as your beams, columns, and posts. But we are laminating now using this cross-laminated technique to create much larger slabs, which can start acting as walls, roof slabs, floor slabs, etc. And by harnessing these 2 sort of raw forms of laminated timber, we can actually start doing some pretty incredible things in that structure. Our business inside of this larger circular conversation, where we're not adding or subtracting anything into the environment, making use of plantation grown timber from our local agricultural sources like your Yorks and your Morenski and your Taquanis, based out of Mpumalanga and KZN. Those are typically the regions we source from. We really focus on procuring that material in various different forms, structurally grading it, finger jointing it into the long lengths that we need, planing, gluing, pressing, and machining, and packaging it for the environment, the project that we're partaking in. We've now recently just added on to our system a slightly better mechanical stress grading system in our finger jointer, and then also included a CNC machining system, which can machine and cut and do all of the interesting things that we need to do to our prefabricated material on a massive scale. So we'll speak about that as well later. We then package it for the environment, and we have many different contractors that we work with to install our products, as far as Rwanda, Tanzania, Botswana, Namibia, South Africa, and I think we sent some stuff up to Singapore last year as well. So it's an interesting concept that we can start shipping building components around rather than shipping raw materials around, which I think is a nice value add story. We typically make use of SA pine. That's our bread and butter material. Sometimes we have eucalyptus come into the factory, but the biggest focus for us is to take this material, which you would essentially see either in a roof truss or on the shelf at a builder's warehouse, and start adding value to that material in such a way that we can create these really high performance building components like floor slabs and massive columns and beam structures. That's really the low-hanging fruit that we see, where we can actually contain the majority of the value chain in South Africa without really being sort of determined by dollar rates or shipping issues. This is a material that we as locals can actually harness from the agricultural sort of growing point all the way up to a final product in our country. Whereas we're seeing with a lot of issues inside of the steel market now, with Mitchell closing down in Vanderbijl and the cement industry going up and down with how they need to procure certain elements of their supply chain external sources, which makes it a bit complicated. So we like to think that this is a 100% local product with a massively reduced footprint due to the fact that we can make here. So as I mentioned, eucalyptus, sometimes a tree for us. It's an incredibly strong, technically hard wood, slightly higher price point, but we're also trying to innovate on that as one of the very few countries in the world that grow this on such a large scale. We can start exporting materials like this to places like Europe and Australia, where we just see such massive performance out of these panels and these beams, simply because of the structure of the eucalyptus tree. But SA pine is more or less what we're working with in the majority. It's the best from a cost perspective. Its durability is absolutely fantastic, and in fact, it's much stronger than people kind of assume. Whereas we even did some tests now. We received some tests from the University of Stellenbosch where we were breaking at S7 grades on material that we didn't really know what the grading was. It was just sort of random material that we sent through, and it started breaking at S7, which is a really good sign for the genetics and the profile of the material that we're using. So fundamentally, from the starting point, I mean, this is a very basic image. It's actually one of the small sort of projects we did for York Timber on their solar expansion project they're doing in one of their mills, where we basically just want to kind of get the fundamentals of this working. So this analogy that I like to use a lot of the time is to consider this material as really big plywood, where you've got a major strength direction depending on how your layups are done. So where that grain direction flows in terms of the long direction of the grain on the outside face of the panel, that is your major strength direction. We can change that in layups, and your wall can kind of do different work as a different component. But we have to consider how this material all comes together, how it all fits together, and how those strength directions start working together. So from a very fundamental point of view, this is essentially how mass timber starts coming to life. There are a lot of different elements that we obviously, as a mass timber producer, I'd love to say that, it's the best material in the world. It's not necessarily a silver bullet when it comes to things like cost. Sometimes we are, in trying to replace something else, we are completely out. Whereas a lot of the times if we just focus on replacing very critical components of the structure, we are pretty much as per conventional pricing. But oftentimes what we see is that it only really takes 3 or 4 of these elements to come together in a project to make it excel as a product. So when you start considering elements like design for disassembly, which is becoming a huge issue with a lot of our international clients with international conditions to their funding, they need to have a proof that they can actually disassemble the structure in 30, 40 years after its use case is complete. Rapid prefabrication and assembly, that's another element that oftentimes wins us contracts, simply because we're about 40% of the time it takes to build a conventional structure, which is obviously a massive yield in terms of getting people renting their structures or living in their structures sooner, meeting ridiculous deadlines, and not having to pay so much for time on site and P's and G's, etc. So there's a lot of different elements, and this is all inside of our design guide, which is on our website, masstimbertech.co.za. It's a free document. It has everything from the sort of design values like load span tables, fire ratings, everything that you need to do a fundamental design exercise, and in fact start engineering with confidence. Another interesting thing about CLT, specifically, I mean, glulam timber as a laminated beam form has been around in our building codes for, I think since the 70s or 60s even. Whereas cross-laminated timber has only very recently entered into the frame. We do, however, now have an SABS sort of regulated building code, which allows us as a producer to then participate in SATAS's auditing system. So we are audited and certified by SATAS, giving us our red stamp, which is essentially the same thing that you see on a roof truss or a normal S5 or S7 graded timber board. We just have our own stamp now for our cross-laminated timber. We get audited quite regularly, and we're required to do quite a lot of testing and sense checking on our work on a regular basis to ensure that we're meeting these standards. So big partnerships with the University of Pretoria and Stellies, where we send material to go get destroyed. and our values sent back to us for, you know, improvement or which is validation. So it is a system which does no longer require any sort of premium on your insurance values. You don't need to do any kind of rational design, and the process of signing it off as an engineer is fundamentally the same as signing off a steel structure or a concrete structure. You know, so council can't push it back on it anymore, and we're able to participate as a normal building material environment. We're also an FSC certified producer, so we can hold and pass on our FSC certification on material, which again is something that especially consulting engineers are quite interested in, because without this, we can't really prove the sustainability of the material. So this is a pretty expensive and quite time-intensive certification for us to hold, but we see that within the next few years, if you don't have this certification, you know, you're just not going to be able to participate in a building contract if it has to do with timber. We're also in the process of developing an EPD and LCA for our materials, so ensuring that we've got the full life cycle assessment complete from source to you know, leaving our gate, cradle to gate, as they call it. It's something that takes a lot of time to put together, but it'll ultimately give us metrics on whether, you know, the material is truly, in fact, carbon negative when it leaves our gate, which we firmly believe it will be. But yeah, it's an interesting study, and this is also going to start contributing to our life being easier in terms of being able to participate in massive contracts which have these requirements. As I said, we work quite well with the University of Pretoria and Stellies. The University of Pretoria, I would also sort of point out that there's going to be quite a significant boom in their timber design and engineering capabilities there. They're developing a whole new lab in partnership with York Timbers and a number of other funders. And there's a guy called Schalk Grobler running that system there. We actually have one of our employees actually work there part-time as well, so that we can kind of participate in that system as well. And we have a number of master students. I think more than steel and concrete interest, the timber interest is taking off massively. So a lot of students starting to develop new techniques, new testing parameters, as fundamental and basic as just validating our pine timber strength values throughout the country, and updating those values for engineers to work with, all the way through to designing new versions of laminated timber, which is all quite exciting, and we're very proud to be a part of. In terms of some of the elements that are also just important to speak about is fire safety. This is something that we get lots of questions about. Again, this is a material that's gone through a significant amount of testing from various different sources in the country and internationally. We have the data now, so we understand how it performs in fire. We understand the build-up requirements. We've managed to design up to a 2-hour fire-rated wall and slab system before, and we'll touch on this a little bit later in the presentation as well. But the big concern really is that we're building really big tinder boxes, and that is fortunately not the case. It's fundamentally very difficult to burn mass timber. Although it is a combustible material, it's difficult to get it to burn and stay burning. So there are really nice methods to ensure that it never has to happen, and there's no reason why this material shouldn't last, you know, for 50, 60 years or longer. So long as we design and detail this material correctly, we shouldn't have too much problems. So let's start talking about some of these projects. I mean, where did we see the sort of initial spike in interest come from, and how are we translating that into a commercial environment as well? So a nice thing for us to work with as a great sort of pitch for clients is to look at things like adding on to existing structures. And what we're doing here is really leveraging the speed of the build, the lightweight nature of our structural capability, and the ability for us to not have to do any serious structural works to the foundations or the walls that hold the structure. So in a case like this, we're adding on this little box to this existing house. We run through the entire process with the project team, the engineer, the architect, the client, where we work this model out in a fully digital space and rationalize it together and get it through to a point where each individual part has been checked and signed off for manufacture. And once we've got that done, we can even do a mock-up build inside of our facility. So in this case, we had a contractor who never worked with this material before, and within 2 days, he managed to actually put up this rather significant addition to someone's house. Just to give you an idea of the scale of the factory, this is all kind of changed around a lot. We've moved our press and we've added on some machinery, and yeah, it's all the factory is absolutely chock-a-block with timber at the moment. So this is a bit of a normal flow that needs an update. But essentially, this guy could basically then bring his truck with all his parts to site and lift it over the electric fence and have a little staging area put together. And they managed to get this building up in about 4 days on site rather than 2 days in a factory. They had a little bit of a tree and electric fence incident to contend with, which made it a bit tricky. But ultimately, a very quiet building site. There's no waste because we've worked everything out to the T. You know, it was such a light touch to the building in the sense that we didn't even have to manipulate the ceilings under which this building is standing or hanging. You know, there's a maximum of about 4 or 5 guys on site, no wheelbarrows, no dust, and obviously no water required to assemble our material. So it's a pretty pleasant system to build with. You know, your guys are clean, the site's clean, and before you know it, you've got the majority of your work done, ready to be signed off. And it's just fundamentally an easier way to build, which we like. It's healthier for the people on the construction site too. So understanding how to panelize these buildings is quite unique. You know, the big things that I'd like to sort of draw attention to is that, you know, we've got a maximum press size, so our blanks are limited to a certain section size, and we have to then kind of start working out how we manipulate these elements into either their floor slab structure. Is it almost like a lintel in its construction over openings? You know, what kind of directions do we need this to be laminated in so that we've got the best sort of resilience and torsion or bending requirements? So as a structure, you start building a bit of like a house of cards together, which needs some attention in terms of how you fasten these things and ensure that you have all your engineering elements worked out. But fundamentally, there's so many different options because we've got things like CNC technology. We've got the concept of carpentry, which allows you to basically create whatever kind of joints you need to solve your problem, whether it's unique or not. Joining these panels is also not as difficult as people might think. You know, there's a lot of fear out there around, oh, well, I've seen the Rotherblast catalog and there's these 3-meter long screws that I don't know how to manipulate. And ultimately, you know, it's really not that difficult. You know, we oftentimes at MTT like to walk the engineers through the process. It's a bit of sort of marketing for us as well to spend a bit of energy at no cost with the project engineer in return for them signing off the building, which I think is a good message for the timber industry in the end of the day. So helping an engineer really get confident around his details, walking into the factory, doing mock-ups, and running through the design values and specifications to ensure that it's buildable, sufficient, and it's obviously going to perform safely as a structure. But yeah, there's endless amounts of details that we can work with, and we often like to help walk you through that process, depending on what the requirements are for every structure. Once the structure is really up and you've got everything connected in the way it needs to be connected, it's really key for us to just run through the concepts of the fact that, you know, laminated timber, especially pine, don't like to be outside. You know, it is a softwood timber. It is predominantly not treated with anything, you know, which prevents things like off-gassing and VOCs getting into the environment. In some instances, we have to do things like CCA treat or Vaxol pressure treat in the material, which is basically just law. We have to do it in certain regions. In Joburg, though, we like to leave it as raw as possible. In most cases, we have a material called Glybor. It's a boron insecticide, essentially, which we apply to our material and then it's soaked in, but it's essentially an inert salt that just makes it unappetizing for bugs, and it's non-toxic to the inhabitants of the building, which is, again, something that's starting to become a bit of a questionable issue. Well, it's a big issue when it comes to what we're putting in our buildings and whether it's healthy for the occupants. In this case, we wrapped it with a Rotherblast Trasper 95 vapor barrier. It's essentially a breathable membrane which protects the timber from sort of liquid water, but allows moisture to evaporate in and out of the barrier. Which just gives the timber a chance to breathe and behave well in its sort of encapsulated form. So this protects it from things like mold and rot, but it also helps it stay stable as we go through different seasons. And it's key that we remember, especially as engineers, that the material is living, and for the architects, it's really key that, the timber does crack sometimes. It is a material that ultimately was grown and not cast or forged. So we have to work within some of those limitations when it comes to protection requirements and aesthetic issues that come out of knots and discoloration being an issue. So again, having concepts like just sort of sticking material straight onto the CLT on the outside layer to protect it. We've seen it done before. We advise against it. It's not really the best way to do it. We want air circulation, but protection with a permeable sort of barrier, to a vapor permeable barrier to allow the material to just stay where it needs to be. Insulation is also important. Although timber's got a really good insulation sort of quality, the issue is that we don't have a lot of density. So when it comes to thermal mass, we don't really hold on to heat too well, and after a very short amount of time, heat can transfer through us as well. So we do advise that insulation is put onto structures. Really, no matter what you're building with in thickness, we suggest that the calculation is at least done, and obviously compliant with the 10800 codes. After this, you then have the opportunity to then clad it with pretty much whatever you want to. So you can go from sheeting to timber cladding to fiber cement, whatever is required. So long as the substructure is capable of handling it, cladding is just what it needs to be. Obviously, protecting the timber as much as possible from water ingress. Timber doesn't mind getting wet. It's just so long as it can get dry in a reasonable condition or amount of time. You shouldn't have any issues. So you'd kind of apply the same logic to a concrete roof slab or any roof, really. You don't want it leaking, so it's just important that this is considered in the build-ups. On the interior, you can obviously leave the material exposed if you like. This client obviously opted to have a drywalling system built in, and they double insulated on the internal and external faces, which made this building incredibly well performing. It was pretty much a passive house structure by the end of this, even though it wasn't really intended. And then it's kind of unique. It's something I can't quite put my finger on, but standing inside of the structure, even though it's a drywall structure, there's something different around the acoustics of the structure, which just made it feel a bit warmer, a bit softer. I really enjoyed the interior quality of this structure. Talking about acoustics, it's also important. I'm sure there'll be a slide that comes up now. Let's talk about it in this next structure. So, quick break from precedent. Let's talk a bit more about why we're doing it. We're oftentimes looking at the construction industry as MTT. We kind of look at where we find benefits for us to really engage with. And so sort of the next big theme is how we work inside of DFMA and use our technology to really elevate our position. So we're trying to really leverage the construction market a little bit further out of its hole in the digitization index by looking at advanced manufacturing and some better communication tools to ensure that we can speed up progression in terms of how we build. So it's another project that we were doing. It's now complete, although it's still under construction. We were asked to sort of develop this 4-story high equitable housing scheme in Zanzibar, with a project team in architect in Poland, an engineer in Stuttgart in Germany, and a client and contractor sitting on Zanzibar Island, and never once being in the same room in person ever. So I don't think we've even met the builder in person either. So it's a pretty interesting way of working. But once we start understanding the tools that we really have available in 2024, it's actually a piece of cake when it comes down to figuring a structure out online. So with a list of parts, a BIM model, and some connection details specified by the engineer, we could actually take this 3D model, which is all timber in its design, built around 3 concrete cores and on a concrete foundation. And we could rationalize the structure into data, which is essentially what it is, what treatments are required, where does it go, what strength grading is it, who's producing it, what's its unique part number, and where does it go in the structure. So by working with this data together in terms of getting a strong specification, ensuring that everybody kind of understands the language more or less, we could really start working with our softwares. We've got quite a nice Rhino and Grasshopper integration that we are just evolving at a massive speed to do work for us, so that we can kind of participate in pretty big projects with I guess what you would call a relatively small team, and work at a pace which is just unbelievable. So being able to use some of these algorithms to lay parts out, adjust them. If there's a change, we can very quickly identify it and push it back into our system and run circles around the engineer to ensure that they're keeping up with what everybody needs. And this is a tool which we just really like to advocate and push forward as Grasshopper and Rhino as a design software. And an organizational software is just incredible in this 3D space. So what becomes interesting, and is something that you have to bring to the table, is that, in a lot of instances, especially with these big full mass timber builds, you just have such an immense amount of components that you have to keep track of and detail differently and have these different specifications done. And this is what we have to contend with on our side. And it's not really anybody else's problem except ours, is that we want to do as much work as possible inside of these sort of closed off, secure conditions of our factory. So we're trying to limit, one of our value adds to the client is that we're limiting, exposure of risk, material risk to a structure, and pretty much 80–90% of the structure in some cases to our structural facility with a business that can't run away with your money, has its own insurance elements in place. So it's a very unrisky way to work in the end of the way, because essentially you have exactly the number of parts delivered to where you need it to be delivered, cut with a robot to exactly the right size, double check, triple check by a QC team, and there's no waste and worry on site when these components start arriving. And if something's wrong, you just get to reproduce another part, and that happens quite quickly. So it's a kind of a unique system for us to work with. It's not as simple as just sort of drawing a line and saying that's brick, let's count how many bricks, maybe use a formula from the 60s to do that, and then we hope we've got enough bricks by the end of the day. So we're definitely leveraging a lot of technology here to make this work. This thing goes onto our robot CNCing system, which is essentially a large-scale industrial robot arm with a big saw on the end. So it's a pretty easy way to explain it. It sits on an 18-meter long linear positioner, which allows us to then essentially have a 3 by 18 meter long CNC bed, which allows us to then cut many different sizes of panels, long 13 meter long GLT beams. We can do individual works on either end and drill holes where we need to. And really the options are quite limitless in terms of what we're doing, where we can change our tool from a big saw to a drill or a routing head. So cutting out your openings for your lights, which is something that people kind of don't think about. When you cast your concrete slab, you wait for it to dry, and then you go and do a big long core drilling session, which takes 7 days to cut out 4 holes. This is where we start leveraging the workability of timber, and also the prefab concept, where we do as much work as we can under controlled conditions as possible. This is essentially what a 5-story high building looks like in flat pack form. So we've got everything from the structural walls, the GLT heavy frame, and then the floor slabs and the roof structure all packed up, ordered into the correct assembly order, tagged, and ready to go. We also did a lot of the steel fabrication, which we obviously outsourced, but doing the different connectors, we helped with the engineers, architects, what they needed, specified that to some of our local contractors, and then bundled the full structure into 4.5 containers, which is quite unique. And it wasn't really exactly like this, but the concept stands really, getting your finished building components, your structural elements together, hitch it onto a trailer, and off you go to site. And this is essentially what it looks like when you hit the site. Again, some of the sort of things that people don't really think about. You've got 3 guys on site here, and they're starting to put together a 4-story high structure. You'll see the cores there in between the 3 sort of main structural areas of the building, with our CLT elements carrying those floor slabs in between those cores. So quite an interesting rapid building system, and I'm quite keen to see this structure go up. You'll note here in the bottom left corner, you'll see our MTT tag with the QR code, having made it all the way to Zanzibar. So essentially, you can go and scan that. And it opens up the sort of drive folder with all of the parts collated to a master model, which you can then go and find that part. So nothing gets lost, nobody gets confused, and it's really fundamentally pretty easy when you think about the fact that you got to lift the slab into place. You got to follow a standard set of drawings which say, put 5 screws in this row at this spacing, and then the building's done. So this is kind of the ease of use that we want to try and bring into the system. What is interesting about this system as well is that you'll see the grooves in the CLT floor slabs. Those are keys for them to pour a concrete floor slab over. So in this case, it was a bit of a hybrid system in the sense that they've got I think it was a 90mm slab thickness in total, with a very thin or very lightweight rebar mesh that goes on top of that, with some exposed screws that essentially tie the concrete and the CLT together. Now, it's a pretty unique system in the end of the day, because you have a really nice ceiling at the bottom, but on the top, you've got a pretty basic concrete floor, which developers really like because they can tile it, they can run many different tenants through it, and it's not a timber floor, which can be quite iffy. It's not a very expensive floor to put down. It also helps with the fire rating. It's a massive addition to the fire rating of the structure. And obviously, because we're going up multi-levels, acoustics becomes very key, especially with a multi-family living situation. You don't want to hear your neighbors so much. Working with that concrete layer on the top and collaborate and sort of unison with one another. You have obviously a much lighter concrete slab. You still have all the benefits of the concrete, and you can build faster because this is basically immediately load-bearing formwork, which you never have to sort of prop or scaffold or move around. It just stays where it is, and this is some renders for the final product. We actually also constructed that sort of dark brown portico out of eucalyptus as well, the sort of external areas as well. So here you're starting to talk about a slightly mixed hybrid system where there's a lot of different components coming together, a lot of different considerations that need to be made to put the thing together. But I seriously recommend that everybody sharpens their DFMA skills, so then I kind of understand how the BIM system works very well. How can you participate in, and where can you really elevate your techniques, where you can. In terms of just touching on fire again, like I said, what's nice about the timber fire system is really that it burns at a very predictable rate. So steel, often you have this really crazy curve that it makes it very difficult to interpret when it might fail or how it's going to fail or where it's going to fail. Whereas with timber, you've got a pretty sort of average rate based on the density of material. And this is, again, improved multiple times with multiple different materials and systems. And it's just really about understanding how you build your layup. So understanding the fire curve, understanding what's required for your specific sort of building condition is really key. And then how you put that together is, I guess, a layer of redundancies and obviously a systems working together. This is actually the Shape project, this 4-story structures floor build-up. So you can see it was 100mm concrete slab there. So we made 128mm 5-layer CLT floor slab. I wonder if you guys can see my mouse, but if you do, you'll see the screws that essentially kind of get screwed halfway through, which basically just tries to bind the materials together a little bit. They're never going to fully bond. Functionally, it's impossible for the two to actually bond. But just to kind of keep things in place and stop them from peeling apart where we don't want them to. Obviously, there's a rebar structure in there. And then this hatched out area is essentially the fire design that we've put together. So you'll see it sits on top of the CLT wall structure. You've got a glue lam beam, which is fastened to that CLT wall structure. And then your CLT slab sitting on top of the both. This European fire engineer suggested that what we do is basically protect the sort of post that we're sitting on with a gypsum layer, which would then obviously slow down that fire sort of indefinitely. So this part of the structure, even if there was a pretty raging fire, would burn so slowly and it would be at so low risk that you can then kind of depend on the rest of this detail to start working together. The idea is also with the concrete slab, which makes it quite nice for people to sort of feel secure and safe, is that essentially this entire hatched gray area can get burnt away and the slab can still function with that concrete layer to allow for, you know, firemen to go and do a rescue or the building not to essentially collapse in an uncontrolled manner. So designing the system in tandem with your fire engineer is actually really key because they give you a full scenario for how they see this thing burning away, but maintaining structural coherence so that you can rescue or demolish the building in a controlled way. So these are really important things for us to just consider. But ultimately, it would have taken, I think this slab was rated for about 1.5 hours in total. So yeah, I think it was 120 minutes for the CLT. So yeah, it's a pretty significant fire rating attached to it, and this is with exposed ceiling. So if you were to go put a gypsum layer on as a ceiling on here, which a lot of our clients do end up doing, you know, you've got a significant fire rating on your hand. In terms of large commercial, we'll jump into this now. Just a quick snapshot of our design guide. Again, just go give it a download. It's well worth the read. Worked quite a lot of put quite a number of hours and quite a number of resources in there. But it also speaks to kind of the systems that we talk about. So we want to walk away from the full reinforced concrete system. We just think it's, you know, concrete's great, but it's probably, we could build slightly more efficiently with it. We can dematerialize it a little bit and walk away from such a heavy frame. And mass timber as a full system, I think it's going to take some time for everybody to be entirely comfortable with that. Not really from a structural perspective, but more from a perception standard. You know, people kind of like heavy things. So we are kind of leaning into working with hybrid sort of systems as a route to market now immediately. So when you go and talk to someone like a Tiber or an Atterbury or a Century Properties or an Attack, they've got a lot of ways that they like to build. They've got systems that they like to work in, and we are just trying to align with a lot of those systems. So in many cases, precast elements like concrete columns and beam systems are really inexpensive. They're really high performance and they work really fast in tandem with a mass timber solution. So that's the system that we like to bring forward. There's been a lot of different studies done on these systems, which again, I've got a couple of resources at the end, which I'll share. But yeah, there's a lot of different systems that have been researched in terms of saying that we can get it to work from a cost perspective, we can get it to work from a structural perspective, and we can start building some pretty insane structures with these hybrid systems working together. Our feeling is really to consider approaching this argument by saying, what's the low-hanging fruit for us to engage with right now in terms of a cost perspective, in terms of efficiency perspective, in terms of a material performance perspective, where are we really going to win as MTT? And we're considering the floor slabs as that low-hanging fruit, where you've got a structural element of a building where the majority of the cost sits in terms of labor, time, contracting, and material mass. And 80% of your building's weight sits there. So that already makes it kind of a no-brainer for us to say, well, we can do slabs. We could do them probably at the same price as a concrete slab and the same performance element. And we've been innovating on that track for quite some time. I don't have a slide to speak to about it here now, but just as a quick anecdote, we've just completed an estimation for a client in Cape Town where we've actually managed to do a timber frame and slab system with a grid spacing of 9 meters by 9 meters, which I think is pretty incredible. And we're running at rates, which is about, I think it's working out to a 1% premium to conventional builds. And this was actually a full mass timber system. So we even have the redundancy to go back and do it with a cheaper concrete frame system. So we're getting there. It's taken 4 years of hard graft, but we're getting to a point now where we're making a pretty strong argument for both hybrid and mass timber systems. So the concept here really is for us to say, well, you go up with your prefab concrete system, and we come in with our floor slabs, and we drop in a concrete topping on that, because it's just easier for a build-up system. And obviously using the elements of sort of structural performance in the right direction to make the system work, and doing our elements like notching and having the correct rebar in the system. With this project, which unfortunately I can't show you the images because it's under NDA, show you this a little bit, but this floor slab, we managed to rate it to a 2-hour fire rating. It is an 11-story high structure, and it works inside of a precast concrete slab, a column and beam system, with our CLT hybrid concrete slab. What I wanted to bring you to was this, where we actually did crunch some of the numbers. Now, this was done independently with an independent engineer from us, and then the next slide by an independent QS, and we've just sort of brought the numbers to the bear. Where floor slab to floor slab, we're about 70% lighter. We're obviously sequestering a hell of a lot of CO2 in the CLT itself. This is not speaking to what we're offsetting in terms of concrete that would have been used. That number is massive. And after we started looking with the project manager at what it would mean for construction time, there was a 40% reduction in overall construction time. Having done those calcs, we could then go to the QS and say, well, look, we know that we're going to come in at a premium because, we're fighting against sand and rock. It's not easy to beat those prices. So ultimately, although our top structure ended up being quite a bit more expensive than a typical sort of RC concrete in situ slab, we managed to reduce their foundation requirements, their piling requirements, the size and sort of thickness of elements on their podium structure that we would be building on top of. The P's and G's were dramatically reduced, the construction time, as you can see, as well. And if you start understanding how those elements fundamentally change the finance picture for the developer in terms of how quickly he could get the building into a rentable state and how much less interest he had to pay on the construction project itself, we could actually make the project less expensive. Okay, it's not by much, about 200 grand, but ultimately it costs less than the conventional building system, with all of the benefits that we've brought forward anyway. So lightweight, fast time on site, and in this case, it was definitely competitive. So as I said, we've got quite a big footprint working out of here in Germiston. It's quite a unique thing that we can produce building components on the scale that we do and put them into containers and send them all over the world, mainly Africa. It's something to speak to in terms of what we can start building and where we can start building. So you're talking about big, large developments that are in very remote and difficult to access sites, where you may need to protect the land. You don't have a big supply chain to back you up with. So building a building of this scale and quality and level of attention on Zanzibar Island is massive. We've also worked with a number of different of these sort of ADU, construction auxiliary dwelling unit businesses like Boxo that build things in the middle of Namibia and in the middle of the Drakensberg, in the middle of Joburg city center. Quite a decent product that they put out, and they put it up in like 3 days. It's absolutely incredible to see it go up. Small additions to York's sort of factory building. We've actually done, we've been inside of a factory before. To big institutional structures, this is work that it's a project which is now complete. We've done, I think, 4 weeks ago. So all of the GLT sort of structure that comes out of this concrete frame. We've done some unique projects with schools as well, so building sort of bench seating out of CLT, which this was kind of they ran out of money and they needed a very quick structural solution, and we managed to put this out quite easily, and it's quite a beautiful result as well. So there's some scope for some interior work as well. It's like, again, working with really big plywood, which is quite cool. We're building some cool things in Pretoria. This is Earthworld's director's house. It's actually done. It's waiting to be dispatched at the moment, and then it's off to construction site. This one's now moving into production. It's a Thai ambassador's residence in Pretoria. We're building out of a heritage structure, which is quite huge, but building these two massive pods. And you'd never know that it was a mass timber structure if you didn't know that it was, in fact, that. But this would essentially be what we're producing. And, it's unique elements where the production of this will take about a month, and it'll be on site for about 2 weeks in your core structure is done. So it's a really rapid way to develop. Complex structures is one of the projects that we sent to Rwanda. It's quite a unique dome shape. This was one of I think we did 4 units, which is 3 domes together. Really nice qualities that timber has in terms of being able to be curved and still maintain a massively structural capability, and go build like these really weird domes in the middle of Rwandan jungle. So we've got a lot of really complex design work, which is entirely resolved in an urban area like Johannesburg with a team that's local, and then sent into the middle of nowhere with very little support from, having sort of hardware or construction supplies nearby or decent labor nearby. A very small team can go build massive infrastructure when it comes to like structural buildings with this material being prefabricated and sent up. And working with Raw Studios now and University of Pretoria as well. And also this is a bit of a plug for that system. There's a timber conference coming up in Pretoria in September, which I'd really advise you go and see what the guys in the timber environment are up to, because we're doing some pretty incredible things in terms of pushing the boundaries of timber structure and being able to bring it into a more complex design language and design capability. We've got a lot of young people that are starting to push the boundaries left, right, and center, which I think is going to make a big influence on how we're building in the future. It's also a project in Pretoria, which is now done. I really need to update this presentation, it seems. Again, this was built in a very, very difficult sort of rainy time. The contractor actually put a tent up over the whole structure. He took the roof off underneath the tent and then just covered this off. I think they were on site for 4 days, 5 days here as well. So really massive amount of speed when it comes to putting these together. So if you're thinking about doing an addition to an existing structure, it's a pretty easy way to do it. We work out, in this instance, very cost effective, and we can do some really incredible things, especially if you start using the timber for its aesthetic value as well. It's not the only reason that you should use timber. It's a flippin' amazing material when it comes to structural capability, especially when laminated. So when people say, "Oh, it's aesthetic," it's not only that. It's definitely capable of doing things which steel does. And with the current environment at the moment for steel, which is just dire, it might be time to start looking at some of these options. Yeah, and this is a building in Kenya that we're also busy working with a pretty strong design team. So good. That's about it from my side. I think I should leave you guys here with a couple of interesting reads. They're not textbooks. They kind of start pushing the thought process a little bit more in terms of how you think about making things, how you start designing it to be made inside of prefabrication systems, but then also, using timber as the means to do so. So I'd highly suggest you go and read some of these books. They're really fun, and they're really insightful, and they'll give you a bit more of an edge when it comes to these conversations. Another book you should definitely go read. So it's being very shameless around this design guide, but I think it's important to give it a read. So that's it from me.